PDF. And then we're also screen recording, so you'll be able to watch this later on if you have questions or don't catch something from the lesson. So we'll go for about 30 minutes, and you can check in with your dad at the end if we need to, but he did send over some stuff for us to work on. Is that what you would like us to look at?
Yes.
Fantastic. So I noticed when I looked at the assignment that there's really kind of a bunch of different types of problems. It looks like you're doing graphs of what I'll call parent functions. But it's like you got a synthesis of them. You've got kind of them all at the end. You've got linear equations, quadratics, absolute values, and so on. Is there one you want me to focus on, or all of them, or what could you give me some more information? Are you able to hear me now? Seems like something may have changed. I am not able to hear you if you're talking. Okay, there you are.
Okay, perfect.
So I didn't hear anything you said, so if you could just restart, I would appreciate it.
Yeah. So your question was, is there anything in particular that I wanted?
Yeah, because like when I look at this, and let me just snip in the first row of equations, so you can just see what I mean. You've already done this. There's 3 different problems types here. There's quadratics, absolute value, and lines, and they're all kind of the same, but they're also kind of different. So was there one of these that was more challenging than another that you wanted us to look at, or is it just in general?
I think it's kind of in general, just graphing has always been my weakest part in math.
Yes.
So I think it's kind of like all of those kind of coming. I mean, I think the fraction one I get the most, but then it comes to the parentheses, and then the absolute value is kind of where it gets stuck.
Okay. All right. So let's do this here. And you're in a traditional classroom, like you're going to school, you're not online at all. Okay. Do you use any computers in the classroom?
No.
No. Okay. All right. So I'm going to switch sharing to Desmos. Have you ever heard of this before, this tool?
Yes.
Okay, I love it. I think it's great for what we're about to do, which is graphing transformations. And do you are any of the transformations like if I wanted to shift this up, how would I do that? Can you tell me that?
Shift it up, you like higher up on the graph?
Yes. All right, that's okay. Let's watch. So let me just demonstrate here. The red, if you're seeing my screen, the red is the parent function, and the blue is the shifted up function. Okay, and it's shifted up 3 units, and see how that number is on the outside of the x squared. So if we wanted to shift it down 3 units, we would subtract 3.
Yeah.
Okay, and that's fairly straightforward. Most students totally get that here. Now, left or right transformations are just a little bit more complicated. They're just odd. Okay, but if we wanted to shift a graph right, notice I use a minus sign to shift it right. And that's counterintuitive. Like you would think, oh, minus, it must be left. We could get into why that is the case, but what you have to know as a student is you have to know that if the number inside parentheses is negative, it shifts it right. If we want to shift it left, well, obviously it's the other way around, it's plus. All right, so any questions on what I've done so far on this?
Yeah, that's good.
Okay, so let me go back to our workspace here. And this is where I want to just kind of formalize that a little bit. So if we have a graph y equals x squared plus c means you're going up or down. And if it's y equals parentheses x minus, and we use a different letter here, k, I'm just picking an arbitrary letter, k, k is either left or right, depending on the sign, okay? So before we even graph, we just need to be able to generally make some statements about transformations that are going up or down or left or right, things like that. So let's look at something pretty straightforward. Let's say I give you an equation like this, x minus 2 squared plus 3. Is x minus 2 a shift left or a shift right?
Shift right.
Right 2 units. Okay, and this 3 is a 3 up or 3 down?
3 up.
So 3 up. Okay, perfect. All right. Let's try another one here. Let's go x plus 4 minus 2. What are the two transformations on this one?
So it would go left 4 units and then down 2 units.
Down 2 units. Okay, perfect. All right. Now, what's interesting and kind of nice is that x squared and absolute value of x, they share a lot of the same behavior. Okay, and we're going to see that next. So I'm going to go back to the Desmos because I really like that tool here. And what I like to do, and this is really good for homework. I know you can't use it in the classroom, but it's at least worth looking at. You're going to use technology in your career someday. The absolute value function is a V, and if you don't like this, actually, let me use the vertical lines. Just be a little bit nicer to look at. All right, so there's our parent function. Now, if I want to shift it right 3 units, I do the exact same thing that I did for a quadratic. It's minus 3. And if I want to shift it up 4 units from there, I do that on the outside. So it has exactly the same behavior as a quadratic, okay? But there's obviously other transformations. So let's go back to the parent function here. What does a negative do when it's outside? Can you tell me that in your own words?
It reflects it over the x-axis.
Over the x-axis, yeah. And then the other one that we sometimes see is a scaling, okay? This 2 made the graph, and depending on how you look at it, you can either sort of use words like stretch vertically is the preferred one, but there's a couple of different ways you can explain it. But we can talk about those types of transformations as well. Okay, but if we go back to the other screen here, kind of look at a problem that you had. So you're going to be given something like this, and your instructor is going to say to graph it. Is that kind of what you're trying to do in this? Yes. Okay. So let's take a look at a quadratic because that's the best case. The quadratic has this form: a x minus h squared plus k. Have you seen that before?
Yes.
What is h comma k?
H comma k is isn't that vertex?
It's the vertex, and it's got some really useful properties. It's either the min or it's the max of the graph. Okay, but why do we care about that? It's because it's the point we need to make a graph. We need the vertex before we can proceed. So if I were teaching a classroom, I would have you as a student learn the table with the parent function in it. Okay, so the parent function is x squared 4 1 0 1 4, and that's the standard U-shaped graph that you've seen. But what's key is that this point right here is the vertex. The vertex always goes in the middle of your table. Okay, so you can act. There's a bunch of different ways you can graph. One approach is to use a table. Some instructors just emphasize like the moving of the points. It's totally up to you how we do it. I'll just show you a couple of different approaches here. So let's take a look at an example here. Let's say I wanted you to graph y equals x minus 2 squared plus 1. Can you tell me the vertex of this?
Would it be?
I didn't hear you if you said anything.
Is it negative 2 or positive 2 comma 1?
So there's a bit of hesitation, right? And it's because is it 2 or is it negative 2? So the standard form is like this, and see how these match?
Yeah.
When they match, you just grab the number. When they don't match, you have to change the sign. And it's kind of like the left shifts and right shifts. It's one of those rules you just got to embed and say, okay, I'm gonna remember that, even though it doesn't make any sense. That's for a different time and place. So the reason we need the vertex is when you're graphing this function, you really want to put that vertex right in the middle of your table. And then you need 2 points that are smaller, 2 points that are larger. And so 1 and 0, 3 and 4. And from here, like one of the things I like to do is I would just tell you to put these numbers into the equation. Is that what you're doing in school, or are you doing something different? Did you say yes? I'm sorry, I just didn't hear.
Yes. Yeah.
Okay. Okay. So y equals, and I'll do it with the 3 here. 3 minus 2 squared plus 1. Okay. 3 minus 2 is 1. 1 squared is 1 plus 1 is 2. Now you've done a bunch of graphing already. Have you noticed there's symmetry?
Oh yeah.
Yeah. So let me actually go back to the graphing calculator tool here. I'm going to graph this one that we've just looked at here. Y equals x minus 2 squared plus 1. And we said the vertex was at 2, 1. Okay. We're excited about that. And the next point we found was 3, 2. Okay. So by symmetry, this point is also going to be over here at 1, 2. And that's what I mean by, have you seen that in class? Like your instructor will say, I need 5 points for your vertex. You need the vertex, but once you get a point on the right, that also gives you a point on the left.
Yeah.
And then when you get another point on the right, you also get another point on the left. Okay, so let's go back to our workspace here. So this 1 is also 2 by symmetry. And then we have a choice. We can either try 4 or 0. A lot of times 0 is a good number, but because we're subtracting, usually want the bigger number there. 4 minus 2 is 2. 2 squared is 4. 4 plus 1 is 5. And if you're careful there, you've got that next point.
Yeah.
Okay. So like when I looked at your assignment here, I saw you graphed 3, really need another point on these.
Okay.
And I didn't see a table either. So that's where I'm like, I wonder what she did. Doesn't matter. But usually for quadratics, they want 5 points.
Okay.
Okay. All right. So what about what I've just done do you feel like you could not do on your own now that you've seen a worked out example?
I think I get confused maybe where like the signs and then I have to flip um like to make it into a vertex. I think I just get confused on which one is the vertex
Got
sometimes.
it. Yeah, that's a very common thing here. So let's look at another one here. We'll see if we can work through that a little bit. I'm just going to increase the difficulty slightly. Let's go x plus 3 squared minus 4. Okay. And sometimes it's good to actually write the standard form right underneath it. And I'm not big on like, hey, let's memorize a bunch of formulas, but you kind of need it for this class. Like it really does help. So the vertex is h comma k. Okay. And k is usually the one you can just grab right away. It's minus 4.
Yeah.
H depends on this. And maybe this helps by like, do the signs match? If they match, you just grab the number. If they don't match, you have to use the opposite of the number.
Yeah.
So it would be at minus 3, minus 4. Okay. And then when you make your table, that goes right in the middle of your table.
Okay.
And you need 2 numbers smaller and 2 numbers larger. Now, when it's negatives, you just got to be careful that you don't put them in the wrong positions. That just could be a little bit awkward when you're calculating it, but this is the this would be the right numbers that your instructor is looking for. All right. So let's do it for we'll just grab minus 4. So let's find we'll put minus 4 into this equation. So it's minus parentheses minus 4 plus 3 squared minus 4. Order of operations, you do the part inside parentheses first. So that's -1. You square it, +1 becomes negative again. So if that wasn't clear here, it becomes -1 squared minus 4. -1 squared is 1. -1 minus 4 is minus 5.
Yeah.
Okay, and which one does this match up with?
The axis or what do you mean by match with?
So there's symmetry. This point goes along with this one down here
Oh,
because we're surrounding the vertex.
right.
Okay, so this is also -5. And you could calculate it. In fact, why don't we do that? -2 plus 3 squared minus 4. Inside parentheses is 1. 1 squared is 1. Then you negate. So it becomes -1 minus 4, which is -5. But the idea is you save time by not having to recalculate it.
Yeah.
So your choice, I would like you to calculate either -5 or -1, please. Doesn't matter which one, just give that a try, please.
So you would. Oh, do you want me to just do it on my paper and then tell you what I get?
Yeah, exactly. This is like the part where you're interacting, or you're so they call this I don't know, there's like guided examples, and then you're doing it on your own. But yeah, I think it's a good part of the lesson to give that a try.
Okay. So when a negative is squared, so it's like -2 is squared.
Yes,
Does that leave it as?
always makes it positive.
Oh, okay.
But the thing is, that negative on the outside, then that comes after the fact. So it becomes positive, but then you immediately negate it.
Yeah.
Do you have a final answer for me?
Um, I think I got, okay, so I got -2 after I did, so I did -5 plus 3 in the parentheses squared minus 4.
Yes,
And then I got -2.
but you have -4 minus 4. So this first part, okay, let me work it out here. So it's actually I have to set here. -5 plus 3 squared minus 4. So you said you get -2 squared, which is 4, and then you negate it.
Oh, right. Okay.
And then you would graph here. You would graph these points if that's what it was asking for. Okay, let's transition to absolute value. So let me give you an absolute value function like x plus 30. I just gave you that one. So let's go x minus 4 plus 3. Okay. So this problem has the same vertex as a quadratic. Okay, it's the absolute value is a x minus h plus k, and the vertex is still h comma k.
Okay.
So it's like even though it's absolute value, you do the same thing. You got to find that middle point, and it's the same rules. So what is the value of h and what is the value of k?
So H is -4.
But see how the signs match?
Oh, right, right. So then it'd be +4.
Yeah. Now that's where I really can't help. Like somehow you've got to figure out how you want to remember that. Like maybe there's a goofy song, or I don't know. There's a lot of ways that you can do that. So we need this point because just like the quadratic, it goes right in the middle. And then you need 2 points smaller and 2 points larger. And there's symmetry again. So you don't have to calculate all 5, you just have to calculate a couple. So let's do it for 5. So let's put value of 5 in. So it's 2 absolute value 5 minus 4 plus 3. 5 minus 4 is 1. Absolute value of 1 is 1, 2 times 1 is 2, plus 3 is 5. So which y value is also 5 by symmetry?
The 3x.
Yes, yes. Okay, so your choice. Can you do either the 2 or the 6 for me?
Yes. So I did the 6 and I got 7.
Yes, and then that's also 7. Now there are some shortcuts to graphing these, but we're definitely not like going to try and do those right now. But what I do want to do is look at, I guess, number 7 on your page. That's probably a reasonable one to look at here. Kind of an exception, but I'm not spending time to graph, but you would plot these and connect the dots and arrows and stuff. But I want to focus on building these tables up today with you, because I think that'll help you the most. Okay, so what type of graph is this? Is it linear? Is it quadratic? Or is it an absolute value?
It's quadratic.
And how do you know that?
Because there's a square.
That's it. Okay, that's all you got to say. Yeah, that's perfect. Okay, now if I write the standard form of the vertex form underneath, and this is where we've been having some issues, but what is the value of h? What is the value of h in this one?
It would be -3.
-3. So the h comma k, -3. Now, what are you adding to this on the right that isn't shown, but it doesn't add anything to it?
0.
Yeah, so if you need to, you can write that k is 0. All right, so now we do the same thing. We create a table. -3, 0 goes right in the middle. And you just got to be careful when it's negatives, because you don't want to go the wrong direction. But negative, the larger ones are actually down here, and the bigger ones are up here. All right, so any questions on this?
No, I think we're good.
I think you got that. Okay, yeah, so let me and I'm not, this is not trying to be critical, but I want to just give you some feedback on this assignment, probably things your teacher already told you about on this. So let's start with the linear stuff here. So here's your answer for number 8. So when instructors are looking for, and I'm just kind of giving you general information. I mean, I'm not grading this. They usually want us to use a ruler. They want to see the lines extend across the axes. So like they'd really want to see this one go a lot further than it does.
Yeah.
Like that. You only need 2 points for a line. Okay, but I had an instructor, a million years ago, and he would actually take a ruler out and he would extend your line and see if it hits some obscure point, way out here.
Yeah.
I mean, I don't know what your instructor's like, but sometimes they're very particular about that. So let me grab another one here. We kind of already talked about this, but when you're graphing a quadratic, you want to see, you generally want to see about 5 points. They're looking for 5 points. And yes, it's U-shaped, but it really is supposed to kind of like go kind of out to the right. And I mean, I've drawn these for forever. I mean, thousands of these. So it's very easy for me to do that. But they also kind of want to see where it crosses if it does. So I could, your instructor may not like your graph because you're missing a few points, and it kind of looks like these are going to come back and hit. But I think if you use the approach we worked on with some tables, I think you'll have some more success on this. So is there is there, my lessons are normally 50 minutes to an hour. We're just doing a shorter one today though, because of the, just to try it out. Is there anything you'd like me to answer real quick on this sheet or the other, before we bring your dad in to talk?
Yeah. So I think the other paper that had 4 graphs on it, and it kind of had labeling that said like Vertex and Directrix and like the focus.
Yes.
So I think that part, like finding the focus and the Directrix, that part kind of confused me.
Okay, so let's do, I have time for, we can do one tonight. We can get to the others. Now, if you book future lessons with me, you can totally dictate and say, hey, Matthew, I just want to work on 7, 8, and 9. This is just kind of a, meet and greet thing. But yeah, we can always do that. So I'm going to send you in the chat, and this is one of my favorite conic sections references. I don't know why there isn't a bet. This one's just fantastic. It's kind of overwhelming at first, but the equations are what really matters, and because that's what you were asking me about here. So you have in this problem is this middle one. I know there's a lot of information here, but if they're going to give it to you in this form where it's a vertex, a focus, and so on, then you have to know these equations. So what's nice is the directrix is equidistant from the vertex as the focus. So if you can imagine the focus is 1 unit away, the directrix is 1 unit away like this. Okay, so this is the equation of the directrix, y equals 1. And they're the same distance, which is really helpful there.
Yeah.
Okay, now in terms of like what these actually are, they're related to things that are communication stuff and some orbital stuff, but for you're just trying to write down the equation of the parabola. So we need the vertex, and the vertex is right there. There's the origin. So the vertex is at 0, 2. Is that okay?
Yeah.
And we can see from the formula here, the vertex is h, k. So we know h and we know k. The focus is at 0, 3. And the focus has formula h, k plus p. Okay, so since k is 2, what is the value of p? K is 2, 2 plus p is 3.
Oh, so it'd be 1.
It'd be 1, so p equals 1. So the whole game in these conic sections, which usually you see that in pre-calculus, I'm not even sure if you're there yet, you have to find 3 variables, h, k, and p. You've found them all, okay? So then you write the equation for the vertical axis, which is given here, x minus h squared equals 4 p y minus k. And then you just substitute in the variables that you found. So h is 0, so it's x minus 0 squared equals 4 times 1, and then y minus 2. And then you would simplify from here potentially like x squared equals 4y minus 2.
Okay.
Now I know that wasn't completely clear, but this sheet is super useful to be able to do these. So like let me really quickly here grab the next one for you. And for number 8, do you see how it opens to the left? It's kind of a sideways parabola.
Yes.
Okay, so in that case, we need the horizontal axis of the conic section formula. So it's the one on the right if you're looking at that sheet that I sent you. So horizontal axis, you can think of it opens, left or right. But it's kind of the same thing. You get the vertex, the point of the vertex here, which is a little hard to read. I guess it's at the origin. Yeah, I guess it's at the origin. Okay. And the directrix, that also can tell you which one it is. It's at x equals 3. Okay. And the directrix is this h plus p. You would see that if you have this. So I'm sorry, it's right there below, sorry, h minus p. So your x is 3 equals h minus p. Your h is 0. Okay, so it's 3 equals 0 minus p. And then you solve for p equals minus 3. Okay, and so you take those values and you plug them back into this original equation, this y minus k squared equals 4p x minus h. So you need three things. You need h, k, and p. We have all three of them. Y minus 0 squared equals 4 times minus 3 x minus 0. So I use the vertex and the equation of the directrix, and I pair them up with the formulas to be able to find the equations for it. This seems a little out of scope, like with respect to the other stuff we were doing, but maybe you're just focusing on graphing in this unit.
Yeah, it's definitely like a lot of graphing. And then I think the stuff we started with was kind of in the beginning of the year. And then recently we just started with focus and directrix, and then the increase and decrease and the domain and range, like all of
Okay.
that.
Okay. All right. Well, hey, is your dad available for some dialogue?
Yes.